joint presentation actually between me and Artemi, which is sitting over there. But what I'm going to talk about here in this presentation is mainly focused on Iceland. And actually also what I'm going to be talking about in the afternoon when I have a presentation about the certification. Because Artemi, he has the luxury of having a whole day actually tomorrow. So he can kind of, use the opportunity then to I guess correct all the wrong things I'm going to say about Spain here today. But so he will have a extra good access to us tomorrow. But there is a difference. Both this presentation and the other presentation I'm giving in the afternoon, they are joint presentations between me and Artemi. But this one, like I said, focuses more on Iceland because we have more currently more data available, and we've been doing kind of more work on wind erosion than they have. But that will be changing with the RECARE process. That's another story. So just to begin with, for those of you that are not familiar with Iceland, it's an island which is kind of characterized by having a very special type of soil, unsay soil, volcanic soil, and I guess many of you are familiar with that soil order. It's a little bit peculiar compared to other mineral soils because it has a very low bulk density. The particle cohesion is very low, and the water holding capacity that this soil has is very high. These soils are by nature very fertile, but the problem is that if you have areas like you have here in Iceland, which are located up in the north, you also have other elements that are interacting with the soil, like temperature, frost. So during the winter you have a lot of frost heaving. So these soils, they become very unstable. If you don't have any vegetation cover, you will have some very serious wind erosion. And this map is simply showing you areas where we have active wind erosion. And these, I'm going to show you the same map actually in the afternoon, because this map here also shows you where we have our deserts. And wind erosion and deserts in Iceland are highly correlated. So this talk in a way is kind of an introduction to the other talk I'm going to give in the afternoon. So wind and water erosion, they are the two primary causes of land degradation in the world. And if you, like I said, if you are in Iceland, you're going to see that wind erosion is a ubiquitous feature in the landscape because of these andesite properties. But the thing is that what is creating really this problem that we are having are really management issues. What is happening today has its roots actually 1,000 years back when people were first arriving and coming according to the sagas from Scandinavia and brought their kind of traditional way of cultivating, and apparently that simply wasn't appropriate, but it took us about 1,000 years to figure that out. And we are still trying to convince some people that the things they're doing today may not be the best ways in order to manage the land properly, but it's a little bit hard to convince some of the I guess we should call them stakeholders. And I have to admit myself that I actually haven't interacted a lot with stakeholders, simply because they tend to have so many opinions, and they're difficult to interact with. They don't believe in you. But this RECARE project actually is going to give us a very good opportunity to change that a little bit. So this is a little bit of a new experience for me. But this is a photo from Spain, and what I wanted to talk about here simply is that even though people may think that wind erosion is not occurring, the fact is that if you have bare soil anywhere, then you are going to have wind erosion. The particles that you're losing may be tiny. I mean, you may be talking about these dust particles really, but the erosion is there. So if you have bare soil somewhere, you have wind erosion. However, these are some photos from Iceland showing actually what the process looks like there. And first of all, it's a process of a global scale, really. You probably cannot see this very clearly, but there are dust plumes here coming from South Iceland that are reaching 400 or 500 kilometers here into the ocean. So this is visible from the space. And the dust actually that is blowing from Iceland can be noticed in the UK and in Europe, as you actually became aware of when we had the eruption in the Erosion, which is just over here. But because of the soil properties that we have, because of the low bulk density, because of the low particle cohesion, then what happens if you have the mineral soil exposed is that you will lose your entire soil profile. It's not like water erosion where you have the seed erosion or wind erosion where you're just losing the fertile topsoil, but we are losing the fertile topsoil, but we're also losing the entire profile. So that is what you're seeing actually occurring here. And here you can see some of these erosion features and how large they can be. You cannot see this here anymore actually because it has blown away. So the landscape that is left behind is something similar to this one. Denuded landscapes with glacial till beneath, so this is really the parent material that is left behind. So we are, in Iceland, in the case of Iceland, we are losing 10,000 years worth of soil formation in just a few decades, really. And it's going to take some thousands of years to rebuild that. And the first step is to convince those stakeholders, which is the tricky part. Seriously, it really is. So this is a photo actually from the area, the case study area that we are working in. And I'll be talking a little bit more about in the afternoon when we talk about the certification. So just to try to put some numbers on this, it has been estimated that we have lost some 240 million up to 1,000 million tons of soil, and it is much more than this. This is a very conservative estimate. And so this is just for Iceland. So we are talking about quite a lot of soil, and this is still happening. This is a photo I took myself a few years ago. And the wind erosion, the effect of wind erosion can be very extreme. We have recently, last year, we published a paper where we were actually describing wind erosion occurring after this eruption in Eyjafjallajökull. And there, well, the conditions are a little bit kind of specific because there you actually get a lot of abrasive material. But this shows you very, very nicely what erosion, wind erosion can do. So what you're seeing here is vegetation that has been totally, really just sandblasted away in just one storm. Just one. It was this storm that took 1.5 days or 2 days. And in this area, 75% of the vegetation cover was lost just in this one episode. So you can imagine when you are in an area like Iceland, where it's absolutely critical to have the vegetation cover in order to maintain the soil. If you have sources of wind erosion, like we had here, that can actually cause this kind of erosion, then you are going to get a very accelerated erosion going on in the area, which is, of course, what is happening. So what are we measuring when we are monitoring wind erosion? Well, we are normally and always measuring some climatic data, wind speed and direction obviously, and relative humidity. But then we are also collecting data on the material that is being translocated, the mass translocation, the particle movement, that's the numbers of particles per time unit, and the kinetic energy. So we have some measures actually on how large these particles are that are being moved around. So to do this, we are using various kinds of equipment. So this is like a standard setup that we are using when we are doing these kind of measurements. First of all, we have dust collectors. which are called BSNE8, if you are familiar with this kind of equipment. It's very simple. It has a small opening here where the dust particles are actually collected in, and you just set the traps at different levels. And then at the same location, you have a data logger which has this sensit sensor here. That is the unit that is measuring these particles, how many particles actually are hitting this gray area down here. And here's another photo of a similar setup with more sensit sensors. So this is actually how we collect data on both the mass, the amount, and the particle size of these particles that are being moved by wind. And here we actually have the numbers, and we actually get the data that we need to correlate with the wind and wind speed and wind direction and humidity and so on and so forth. Other thing that we actually do is to use this wind tunnel that we have, and that's absolutely critical for us to know if we want to know, which we do, to know where the threshold is in different areas. What wind speed you need to have in order to start having particle movements, and this is something we are doing when we are evaluating like land reclamation areas where we are working in, and it gives us a nice measurement of resilience, system resilience. So this is the area, the RECARE area that we are proposing. It's a 900 square kilometer area in Iceland, here in South Iceland. It's been delineated here by these black lines. These greenish areas are actually areas where we have been doing various kinds of land reclamation operations, and some of the oldest ones are since 1907. One example of data that we have, this is actually from the northern part. This is an experiment where we were actually measuring and mapping channels, wind channels, local wind channels. So where the sound drift actually is occurring, and where it's going, where the sources are and where it's going. So this is something we typically do when we are doing these kind of studies. So this is the end slide that we are provided with, and this happens also to be the end slide of my presentation.
Thank you.